We hear all the time about these big scientific discoveries, right? These huge theoretical breakthroughs that like change how we see the universe.
Yeah.
And you kind of picture, right, a lone genius in some lab coat having this, sudden flash of insight like, I've got it.
Right, right.
But, you sent us a super interesting article that makes you kind of step back and say, wait a minute, what's the real story here? Like, how did these discoveries actually happen?
That's such a good point because, that article we're talking about, the one with that experimental cosmologist, Dr. Brian Keating, talking with Fraser Cain,
Yeah.
that really gets at something crucial, something that often gets overlooked. It's like the whole world of the experimentalists.
Right.
And that's what we're going to dive into today, right?
Yeah.
Like, why are these individuals, these experimentalists, so vital? Not just to cosmology, but to science as a whole.
Totally. Because you think about it, right? These grand ideas about the universe, the Big Bang, dark energy, cosmic inflation.
Mm-hmm.
How do we actually move beyond just the theory? Like, how do we even begin to test if these ideas hold water?
Exactly.
And that's where someone like Brian Keating comes in, right?
Totally.
So to start us off, what exactly is an experimental cosmologist?
Well, in his own words, Keating really nails it. He says it's all about building the instruments to actually put these mind-blowing theoretical ideas to the test. It's not just about thinking deep thoughts. It's about the nuts and bolts of designing and building the telescopes and detectors and all the stuff that actually gathers the data from out there in the cosmos.
So it's really hands-on.
Oh, absolutely. It's like the ultimate hands-on science. And what's so cool about Keating's perspective is that he kind of flips the script on how we usually think about scientific progress. It's not just about these eureka moments of theoretical brilliance, right?
Mm-hmm.
It's about the often really tough, unglamorous work of testing those ideas. And get this, trying your hardest to actually prove them wrong.
That's interesting. So it's almost like they're trying to break the theories?
Yeah, exactly. Break them if you can. That's the real test.
Yeah.
And, he talks about going to some seriously extreme places to do this. The South Pole, the Atacama Desert.
Yeah, I was going to say that's not exactly your typical office environment.
No kidding, not at all. These locations are chosen for a reason, though.
Right.
Like the super thin dry air at high altitudes, it's like gold for certain astronomical observations. Because it's so clear.
Oh, right.
But can you imagine the logistics of just getting this sophisticated equipment to these remote places and then keeping it running in those conditions? It's insane.
Yeah, that sounds like a whole other challenge in itself.
It totally is.
Yeah.
And Keating uses this great analogy. He compares theorists to architects, right? The ones drawing up these grand designs.
Yeah.
And the experimentalists, he says they're like the engineers and the builders, the ones who take those plans and make them into something real and then really put them through their paces.
I like that. That's a great way to think about it. You've got the theorists with their equations and simulations, and then you've got the experimentalists out there wrestling with the actual universe.
Exactly. Wrestling with reality. And that really shifts your whole perspective on how science actually moves forward.
It does. And speaking of perspective, Keating seems to have some pretty strong and often pretty funny opinions about how each side gets recognized.
Right.
That does.
He does. And it's hilarious, but he's also making a really important point.
Yeah.
He's basically saying, look, theorists often get more of the spotlight, right?
Yeah.
They get the Nobel Prizes. They're the ones making headlines.
Yeah, you see their names more often.
Exactly. But the experimentalists, the ones doing what he jokingly calls the grunt work, they often stay kind of hidden.
It's true. They're the unsung heroes.
Totally unsung heroes.
Yeah.
And he even makes this comparison to software engineers. They can write code pretty quickly. But experimentalists are out there physically building these insanely complex instruments in the harshest environments imaginable.
Yeah, and like we were talking about, just getting basic supplies to some of these places is a huge hurdle.
Oh, totally. Like even something as simple as getting fuel to power your equipment at high altitude, that can be a nightmare.
It really highlights how much more there is to scientific progress than just having a brilliant idea.
It does. It really does. I mean, science isn't just about coming up with amazing insights. It's about testing those insights. And that means actively trying to find evidence that might prove them wrong.
And that's the experimentalist's job, right? To be the ultimate skeptic.
Exactly. They're the ones who put these theories to the test up against what we actually observe in the universe.
That makes their role even more crucial then. It's like they hold the keys to the kingdom.
I like that. The keys to the kingdom. Because they can unlock the truth. So speaking of testing ideas and pushing the boundaries, Keating's involved in this massive project that really showcases all this. It's called the Simons Observatory.
Yeah, tell me more about that. What exactly is the Simons Observatory?
Well, it's a huge undertaking.
Yeah.
And it's all about studying something called the cosmic microwave background, or CMB.
Okay.
Now, just so everyone's on the same page, the CMB, It's basically the afterglow of the Big Bang. It's this super faint radiation that's literally everywhere throughout the entire universe. Yeah, it's mind-blowing. And by studying its properties, cosmologists can get incredible information about the very early universe. Like right after the Big Bang happened.
So they're looking back in time almost.
They're looking way, way back in time. And they use this information to test some of the most fundamental theories we have, like cosmic inflation.
Okay, remind me what cosmic inflation is again.
So cosmic inflation is this idea that the universe expanded super rapidly, like crazy fast, in the first 20 fraction of a second after the Big Bang.
Oh, right, right.
And studying the CMB can give us clues about whether that rapid expansion actually happened or not.
Wow. So these telescopes they're building for the Simons Observatory, they're designed to detect these incredibly faint signals from basically the dawn of time.
Exactly. That's what they're doing. And Keating really emphasizes how much goes into this from the experimentalists' side. It's not just about the high-level physics. It's about managing crazy budgets, leading these huge construction teams, and even dealing with super practical stuff, like making sure the concrete they use for the telescope foundations cures correctly in this remote high-altitude location.
Wow, I never would have thought about that.
Right. It's easy to forget that even the most abstract scientific pursuits still have these very real logistical challenges.
Totally. It's a far cry from that image we have of a lone theorist just scribbling equations on a chalkboard.
It really is. Yeah. And it's so cool that Keating is also super dedicated to sharing all of this with the public.
I'm so glad you brought up that public engagement piece because you sent us this article about Keating. So you're clearly interested in how this kind of fundamental science gets communicated to a wider audience.
Oh yeah, definitely. It's something I think about a lot. Because Keating believes that since he's funded by public money, he has a real responsibility to connect with the public and make science more transparent and understandable.
I love that. That's a great attitude to have.
I think so too.
Yeah.
And he does this through his YouTube channel and his podcast where he has these really in-depth conversations with some of the biggest names in science, like Roger Penrose and Brian Greene.
Oh, wow. I'll have to check those out.
You should. They're fantastic.
Yeah.
If you're curious about the universe and like the biggest questions in science, it's a great place to start.
Awesome. And I've got to say, I loved that quirky little detail about him giving away space dust meteorites to people on his mailing list.
Oh, yeah?
That's such a cool and memorable way to connect with people and promote his book.
It really is. It's so creative. It just makes cosmology feel so much more real and sparks that curiosity. And it shows that his commitment to public science goes way beyond just, giving lectures. He really wants to create a real connection.
That's fantastic.
Yeah.
Now, I think there's sometimes confusion about the different types of astronomical observations that are out there, especially with all the excitement about the James Webb Space Telescope. So how does Keating view the relationship between that and the kind of work he does with CMB telescopes?
That's a great question because they both give us these incredible views of the universe, but they're looking at fundamentally different things.
Right. They're like different windows into the cosmos.
Exactly. And Keating makes that clear. He says, look, the James Webb Space Telescope, it's an amazing instrument. It's observing galaxies and stars in infrared light, which is a kind of light we can't see with our eyes, but it lets us see through all the dust and gas that blocks our view.
So it's like it lets us see farther back in time.
Exactly. It's giving us these amazing views of the early, large-scale structure of the universe.
Yeah.
But it's not directly observing the very beginning of time in the same way that CMB telescopes are.
Okay. So it's a different kind of time travel.
It is. It is. And he uses this great analogy. He says, think of the JWST as this super powerful infrared microscope. So you're looking at individual celestial objects in incredible detail.
Like zooming in.
Exactly, zooming way in. But then he says, think of CMB telescopes as an X-ray for the universe's bone structure.
That's a cool way to put it.
It is, right? Because you're seeing that primordial light from like 370,000 years after the Big Bang.
Yeah.
It's like looking at the universe's baby picture.
Because they're both giving us these amazing pieces of the puzzle, but they're different pieces.
Exactly. They're complementary tools. They're giving us different but equally important information about how the universe works.
It's like they're each telling us a different part of the universe's story.
I like that. Different chapters in the story. And, behind all this practical work, all these observations, there's a really specific philosophy that guides Keating's approach to science.
Oh, interesting. Tell me more about that.
So his core belief is that true science, it's not about trying to prove ourselves right or confirm our existing biases. It's about constantly testing the limits of what we know and being completely willing to throw out ideas when they don't match the evidence. He has this great quote. He says, I'm not in the business of proving theories right. I'm in the business of proving everything else wrong.
That's a pretty powerful statement. It really gets at the heart of what science is all about, that constant questioning, that willingness to let go of what you think you know.
It really does. It shows the humility at the core of science, the idea that what we know right now, it's always subject to change as we learn more.
And I have to say, I really appreciate that Keating brings a sense of humor to all of this, too.
Oh, yeah, me too.
Like when he jokes about maybe not winning a Nobel Prize being a good thing because then he wouldn't have to retract his book if he turned out to be wrong.
Or when he teases the theorists and software engineers for having it easy compared to the experimentalists out there battling frozen equipment and tricky concrete.
Yeah, or even that little bit about Fraser's mild superpower meteorite.
Exactly. It's all these moments of humor that not only make the conversation more engaging, but also highlight the different perspectives in science. You know, the theorists versus the experimentalists, they face different challenges, but they're all part of this grand quest to understand the universe.
It humanizes the scientists too, right?
Oh, totally. It reminds us they're just people like us, trying to figure things out and having a laugh along the way.
So bringing it back to our listener here, why should they care about all of this?
Well, I think this whole conversation gives us a really valuable look at how scientific knowledge is actually built and how it's validated.
Yeah, it's not just these abstract ideas floating around out there.
It's not. It's grounded in this really demanding hands-on work.
And the challenges the experimentalists face are huge, like all the logistics, the building and operating this sensitive equipment in these crazy environments.
It's mind-blowing when you think about it. And it really shows that even our most fundamental understanding of the universe, it comes from these very practical, very human efforts.
Right. It's not just about the genius having the idea. It's about all the people who make it possible to test that idea.
Totally. And maybe even more importantly, Keating's whole emphasis on rigorous testing and that willingness to be proven wrong, that's not just relevant to cosmology.
Oh, yeah, that's a valuable mindset no matter what you do.
Absolutely. It's
Oh.
something we can all learn from or feeding. Being open to challenging our own assumptions, actively looking for evidence that might contradict our beliefs. That's how we learn and grow in any field.
So to sum it all up, what's the one big takeaway from this whole deep dive?
I think the biggest takeaway is that experimental cosmologists and experimentalists in every area of science, they're absolutely essential for scientific progress.
Without them, we'd just be stuck with theories.
Exactly. They're the ones who design and build the tools, often in incredibly difficult conditions, to test our biggest and most profound theories.
Yeah, they're the ones who actually make the science happen.
Totally. Without their dedication, their creativity, their willingness to get their hands dirty, so many groundbreaking ideas would never move beyond the whiteboard.
It really makes you think, doesn't it? Consider all the builders in other fields that you're interested in. You know, the engineers who test the bridges, the people who make new technologies work, the ones who find the flaws. How does understanding their role change how you see progress in those areas? It's something to really ponder.
It is. It really is.
And if you want to explore this conversation in more depth, you can find the full article, Brian Keating, Why Experimenters Are the Unsung Heroes of Science, hosted by Fraser Cain.
Definitely worth a read.
Okay, thanks for joining me for this deep dive into the world of experimental science.
You got it. It was a lot of fun.
And until next time, keep those questions coming.